Algebra 2, lesson 75, we're talking about graphing radical functions. A lot of what we're going to deal with is different forms of radical functions. So a radical function is a function written in one of two forms with a radical or with a fractional exponent. So we can write y equals the nth root of our function gx, or we can write y equals gx to the 1 over n, and that's going to end up being the same thing. Okay? In each case, n is an integer and gx is a function. In the case of the radical version, the n is also referred to as the index. A radical function is the inverse of a power function, and that's what we're going to look at a little bit today, is how to write the inverse of a function. How many of you remember how to write the inverse of a function? Or we have two rules, right? Emily, what's the first rule of writing an inverse of a function? Switch the x and the y around, right? And then what's the second step, Lexi? Solve for y, right? If we can do those two things, we can find the inverse of a function, okay? All right, and that's pretty much all the book is going to give you. It doesn't mean that there's not more questions than that, but we're going to look at some of them. So question number 1 says, what is the inverse of y equals the cubed root of 8x plus 24? So we want to find out what y equals. So our first step, according to Emily, was to do what, class? Switch the x and the y. So what would I end up writing for this function? X equals, Christian, keep going with it. Cube root of what? 8y plus 24. Okay, so the first thing that I need to get rid of is I need to get rid of the cube root. How do I get rid of the cube root? Cube everything, right? Cube both sides. Okay, so we're going to cube both sides. When I do that, what does the left-hand side become? X to the third, and what does the right side become? 8y plus 24. Can we progress to solve this from here? Does this look like something that we can do? Right? Because what's the second step, Lexi? What did you say? Solve for y. So in solving for y, what do I have to do? I have to what? Subtract. So I think what we're getting to, hopefully, not necessarily, maybe you're not reading my brain here, but we're trying to isolate y, right? We're trying to move everything else away from y. I did here subtract 24. Okay, so we're going to subtract 24 from both sides. That's going to leave me with x cubed minus 24 equals 8y. Okay, I still have something attached to y, though. How do I get rid of it? Divide by 8 on both sides. There we go. All right, so, and I know my work's kind of everywhere here, but y equals what? What is 1x cubed divided by 8? How can I rewrite that? 1/8 x cubed. And what is negative 24 divided by 8? Negative 3. So I'm going to get y equals 1/8 x cubed minus 3. All right, is that doable? Can we do that? Okay. So later on, what we'll do is we'll actually graph both functions, right? We'll show how a graph of a function differs from its inverse. They're not perpendicular necessarily, okay? They're going to meet at different angles, okay, but not necessarily perpendicular. All right, so don't make any assumptions over inverse functions being just opposite reciprocal slopes. Okay, it's not always like that. All right, do we understand how we solve number 1? Okay. I will erase that then. All right, number 2. Find the domain of the square root function. This does not say find the inverse of the function. It just wants the domain. So the domain is the possible x values. Okay? Now, for my possible x values, right, if we want the real values for x, so we don't want anything that's imaginary, correct? Right? We want real values for x. So, because my x is inside of a square root, what can I not have inside of a square root, or what inside of a square root would make that imaginary? Does anybody know? If it was a negative, right? So if I had a negative inside this square root, that would make it imaginary, correct? So what we're going to say is that 8, sorry, let me write here, that 8x plus 5 has to be greater than what? Greater than what? To be positive, right? It can't be negative, so it has to be greater than or equal to what? 0. It has to be greater than or equal to 0. I'm going to try to fill that in. So can I solve for x in this? Okay. How? What do I do? Subtract 5 from both sides. So we know that 8x has to be greater than or equal to negative 5. What else? Divide by 8. Divide by 8. So x must be greater than or equal to negative 5/8 in order for it to be 0 or greater than 0. Does that make sense? So x, we would say, if we were going to write out the whole domain, x is a set of all real values such that x is greater than or equal to negative 5/8. That would be the whole domain of that function. Okay, but all they're asking for is a. Okay, so if they're asking for domain and my x is inside of a square root, we're going to take everything that's inside that square root and we want to set it greater than or equal to 0. Does that make sense? We understand that? Okay? All right. Can I erase this? Did we all write that down? I see some people not writing anything down. That's a problem for me, right? We're not taking down any notes. All right, let me walk around the room and make sure that we're actually working these problems out as much as we can. Okay, some of us are doing better jobs than others. Okay, listen, it is my job to teach you, but you still have a job in here, right? You still have a responsibility to yourself to make sure that you understand this when you leave. All right, because I don't go home with you. Praise the Lord. Okay, I think we would both agree that that's a great thing. Okay. So, but the only thing that you can take with you, right, is what you take with you. All right. 3, we want to graph y equals the square root of 6x plus 3. Okay? Let me look at my notes here. So what I'm going to do with this is I'm going to plug this in a graphing calculator. But notice, can I substitute anything in for f of x? Y. So I can rewrite this as y equals the square root of 6x plus 3. Okay? Does that look similar in any way, shape, or form to a slope-intercept equation? Okay? What would be the y-intercept in that equation? 3. So we would expect that this equation is going to intercept the y-axis at 3. Now, does it look like a linear equation? This whole square root of 6x, does that look like it's got a linear equation? Does it have a fixed slope? We haven't really seen anything like that before, right? All right, so let's try this. Okay, we've got y equals, and I got a whole bunch of people that still come in every day, don't have a graphing calculator, never grab one, right? My 2 boys up front, why don't you go ahead and grab a graphing calculator so you can practice this. Okay, they're right there. All right, so this is monkey see, monkey do. You're going to hit y equals. You're going to hit second, and then x squared. That's going to give you your square root. You're going to type in 6. Then you're going to go up to link. You're going to hit x. Then you're going to close your parentheses. That's going to make sure that 6x is all underneath the radical. Then we're going to hit plus 3. Okay, plus 3. Is everybody caught up with me? You guys here? Let's see how we doing. Okay, now you want to go outside of that, so you're probably going to want to hit your arrow. No, you had it, and then you went back and deleted it. Nope. Okay, you had it, and then you deleted it. Second square root 6x. Right? See how all of that's underneath the radical? Arrow. Okay, that's going to take you outside of the radical, or radicand, plus 3. Got it? Okay, next thing you're going to hit is graph. Okay, graph. So we're going to hit graph up here. We're going to see what that looks like. Okay, does this still touch the y-axis at 3. But is it linear? No, it's not linear. It has a curve to it, right? So as I look at some of my examples, right, we know that it's not A or C, correct? Is it B or D? B, right? Because D is shifted over a little bit. Doesn't actually, I mean, it does almost touch at Y, but we can tell that ours is B. Okay, so do we know how to plug some of these into our graphing calculators and find the right graph? Great. All right. Let's come down. We'll clear this out. Let's go down to this next question. Graph the cube root function of f of x equals 4 times the cube root of x plus 2 and identify its domain and range. Okay, identify its domain and range. So let's go ahead and let's plug this into our graphing calculator. Okay, we're going to go back into y. We're going to clear that first one out. So this is what I'm going to do. I'm going to hit 4. Then I'm going to go to math. I'm going to go down to number 4. You see how this is a cube root? Okay, we're going to hit enter on that. X plus 2, close parentheses. Okay. Are we all ready to graph? Okay, let's hit graph and we'll see what this looks like. All right. Moving this guy around. Notice that it crosses the x-axis at where? Where does it cross the x-axis at? Where does it cross the x-axis at? -2. Very good. Okay. So, and it kind of comes up to 1, 2, 3, 4, about right around in 5, something like that. Is this similar to anything that we see in here? Is it like A? No, it's not that flat. Is it like B? No, because I mean we know it comes crosses up here at about 5. Is it like C? Could be. Okay. Let's see. So there's only really C and D look pretty similar, right? All right. Let's go back to our graph and take another look. All right. Now take a look at it. Does it look more like C or D? C. All right, C. So we're basing our domain and our range upon the graph. Domain is how far it goes to the left or right. Okay, how far does it go to the left or right? Does it ever stop going left or right? No, so we would say our domain is all real numbers. Okay, positive and negative. Does that make sense? Okay, what about our range? Range is up and down, right? Our y movement. Does it ever stop going up and down? Does it stop going up? No. Does it stop going down? No. So our range is a set of all real numbers. So do we see how our answer for C down here matches with what we see in that graph? Hopefully. All right. Let's look at number 5. Okay. Graph the square root function and its inverse. And its inverse. Okay, so well, first off, let's try to graph what we see there. Y equals x plus 3, or sorry, y equals the square root of x plus 3. So square root of x plus 3. All right, let's see what that looks like. Okay, we'll graph that. Okay, so what we notice there is that it's curved, and this tells me right here that it's 3 to the left on the y-axis. So as I go to draw this, okay, what I see is I'm here, I'm drawing something that kind of looks like that. You follow me? Yes? Okay, now let's do the inverse. Okay, we have y equals square root of x plus 3. So in order for me to graph the inverse, I have to know what the inverse function is. What's rule number 1 of finding the inverse? Switching the x and y. So x equals the square root of y plus 3. All right, how do I get rid of a square root? Square both sides. So we have x squared equals what? Y plus 3. All right, I want to solve for y. What do I need to do? Subtract 3 from both sides. Very good. So I get y equals x squared minus 3. Y equals x squared minus 3. So now we can come over to our graphing calculator. Okay. Oh. Come down here just so we can see the difference. X squared minus 3. Okay, and it's going to show me a parabola, but I really don't want the whole parabola. I don't want this negative left-hand side. Okay, so what we're going to graph is going to pick up from negative 3, and it's going to go like that because we want the inverse portion of it. Okay, so we see that this is my blue. Right, that's my red line. So those are inverse functions of each other. You follow me? Okay. All right. Let's see. On number 6, we don't actually need to do number 6. Does anybody know why we don't need to do number 6? It's the exact same question. I don't know why it shows up 2 times, but it does. And so number 7 is our last question. It says find the inverse function. It's not asking for an equation. It just wants the inverse function. Mimi, how would I find the inverse function of this? What's the first step? All right, so we're going to get x equals y minus 6 cubed plus 9. Okay. What's the next thing I can do? Anybody know? Nope, can't distribute. Not yet. Actually, I won't end up distributing it at all, I don't think, in this. Okay, we're trying to isolate y. What's the first thing that can go? Subtract 9. Minus 9. So I got x minus 9 equals y minus 6 cubed. How can I undo something cubed? Cube what? Not cube both sides. Cube root both sides. Okay. All right, so now what I have is I have the cube root of x minus 9 equals y minus 6. What do I want to do with that 6? Add it to both sides. Now, is that positive 6, is it going to go inside the cube root or is it going to stay outside? Outside. So we're going to say that y equals the cube root of x minus 9 plus 6. And that is our answer. That is the inverse function of what we just saw. This is my answer right there. All right, I believe your assignment numbers and everything have been sent to you. I know this is kind of a tricky lesson, but do your best. If you got questions, let me know. I'll walk around and help you out. All right, very good. I'm glad we were able to get done with this on such a short day.